Hi, everyone. This is Dr. Robyn MacKillop with our math session for Get That GED. And today we're going to do two-step algebraic equations and likely some distributive property equations. So let's get going. I'm going to switch my camera. All right. So I'm going to do a super fast review of just a single step equation. And that would be something like x minus 5 equals 16. And this is the basis for algebra and what you need to do in geometry. You will come back to these all the time. So if you're comfortable with them, awesome, because this is it. If you can do these, you can do most of algebra and you can do all the geometry. All right, so what we've got here is x minus 5 equals 16. And what we want to do is get one side as a variable only and the other side as a single number. And so what we're looking at here is this minus 5. It's kind of an outlier. We got to get rid of it. And to get rid of it, we have to zero it out. We've got negative 5. What will make that 0? If we add 5. Negative 5 plus 5 is 0. So that's gone. But we have to do the exact same thing on this side. We have to add 5 here. So these are gone. That leaves us with x equals 16 and 5 is 21. X equals 21. And you can check your work. This is the cool thing. You can always check your work by taking this number and substituting it for x. So 21 in place of x minus 5 equals 6. Perfect. All right, so that was a one step. You didn't have to deal with any extra numbers around the variable. Except let's go to the step equations. So a two-step equation, you're going to do something like this twice. That's all that means. It's the same process no matter how long they get. All right, let's do number 1. 3x minus 5 equals 16. So we still are going to get rid of this extra 5 first. 3 and x, when a number and an x are together like that, that's a multiplication problem. That is 3 times x. Minus 5 equals 16. Our goal is still to get to one variable and one number. So let's get rid of the 5 like we did before. We're going to add 5 to zero it out, which means we're going to add 5 to this side. For now, we're ignoring 3x. We need to get rid of the extra number. So this is gone. Bring down 3x equals 16 and 5 are 21. So first step is done. Now we're going to do the second step. We need to separate the 3 and the x. Because it's multiplication, we're going to use the opposite. Like up here for subtraction, we use the opposite to zero it out, addition. The opposite of multiplication is division. Did I say that right? The opposite of subtraction is addition. Opposite of multiplication is division. We do the exact same thing over here. 3x divided by 3 is just x. 21 divided by 3 is 7. Now we can check our work. We can take that 7 and plug it into the original equation. That would be 3 times 7 minus 5 equals 16. Or 21 minus 5 equals 16. We did it right. Cool, huh? All right, let's do some more of these because that might have been, it's kind of long. But again, it's the same process. no matter how long these equations get, you are doing the same thing one step at a time until you get to one variable and one number. Let's do number 2. We've got 7x plus 3 equals -4. And the first thing we're going to do is get rid of that extra number. We're going to get rid of that 3. And because it's +3, we're going to take away 3. And that's nothing. That means 0. But we have to do the exact same thing over here. So these are gone. And now we have 7x equals -4 and -3 is -7. And then once more, we need to separate the 7 from the x. We're going to divide out that 7 on both sides. X equals -7 divided by 7 is -1. And we can always plug it right back in. 7 times -1 would be -7, plus 3 would be -4. All right, let's do a couple more of the multiplication, and then we'll do the division. When you've got a fraction, that's a division problem. All right, let me see if any of these are really bad. Nope, none of them are terrible. All right, so we'll do number 4, number 5, and then we'll do 3 and 6. So -14n minus 7 equals 49. I'm gonna need some water. My throat is going again. All right. So again, we've got this extra 7. We're going to get rid of that. We're going to add 7. That is zeroed out, but we have to add 7 over here. So bring down your -14n. You're done with that. And then 49 and 7 is 56. Now, you want to separate that -14 from the n. We're going to divide it out. And we're going to do the exact same thing over here. So -14n divided by 14, -14 is just n. And 56 divided by -14, good guy leaves town, bad for the town. And I believe 56 divided by 14 is 4. So n equals -4. And for those of you who don't know my little, for multiplying and dividing negative numbers, this only works with multiplication and division. It does not work with adding and subtracting. Good guy goes into town. It's good for the town. The good guy leaves town. Bad for the town. The bad guy goes into town. Also bad for the town. Or the bad guy leaves town. Good for the town. So that's how I said good guy leaves town, bad for the town. Cool, huh? Super easy way for only multiplying and dividing. All right, let's do number 5. We've got 2n plus 45 equals 15. And here we need to get rid of the extra 45. That's just kind of an outlier. We're going to take away 45 because that's now 0. we have to do the exact same thing on the other side of the equal sign. So 15 minus 45 is negative 30. Equal sign, bring down your 2n. We need to separate the 2 and the n. So we're going to divide out the 2, do the exact same thing over here. And we've got 2n divided by 2 is n, and negative 30 divided by 2. Bad guy goes into town, bad for the town. 30 divided by 2 is 15. Cool. What do you guys think? Are you feeling that? Is it making sense?
Yes.
Awesome. All right, let's do a couple of the division 2-step problems. That would be number 3, 2 and 3, or 3 and 6. Yeah, 3 and 6. So let's do number 3 first. We've got x over 2 plus 2 equals 4. We've still got this extra number, so we're going to deal with that first. Don't even worry about this until you clean up this. And again, we're going to get rid of it by subtracting it to zero it out. Do the exact same thing over here. And that gives us, bring down your x over 2 because you haven't done anything with it yet. That is gone. Bring down your equal sign. 4 minus 2 is 2. Now we can deal with the division problem. And just like before, the opposite of multiplying is dividing. The opposite of dividing is multiplying. We are going to divide this, or sorry, we're going to multiply this by 2. Whatever your denominator is, that's what you're going to multiply this by. That means you're going to multiply this side by 2. This cancels. So you just have x. And then 2 times 2 is 4. Now, does anyone want to see how that works? There's a long way that I can show you to show you why this works. This is a shortcut to a very long, drawn out process. Anytime you have a regular number, 2, 3, 4, 5, 100, a million, you can turn a regular number into a fraction by putting it over 1. So if you ever get a problem where they give you something like 3 over 4 plus 2, granted, you can just do the addition. It's 2 and 3/4. But if you need to show your work as a fraction, you turn both that number into a fraction as well. And it makes it a little bit easier. So what happens here is we have x over 2. This is the same problem we just did, equals 2. When I say divide or multiply this side by 2, you're technically multiplying it by 2 over 1. And what you get is when you multiply fractions, you multiply straight across the top. That's 2x. Multiply straight across the bottom. 2 times 1 is 2. And 2x divided by 2 is plain old x. So you can save yourself this work just by multiplying by the denominator. But just in case, for those of you who want to know why that works, that's why it works. Because technically, you're multiplying by 2 over 1. You're multiplying this fraction by another fraction. It comes out to 2x over 2. The 2's cancel and just give you x. So hopefully that makes sense. And then don't forget to do your fancy stuff to that too. 2 times 2. All right. Hopefully I didn't throw you off. Let's do number 6, which is n over 5 plus negative 6 equals 9. This can also be written as n over 5 minus 6 equals 9. These are the exact same problem. So whichever one works for you, if this makes more sense to you, use it. If this one makes more sense to you, use it. But anytime you've got plus a negative, it's as if the plus sign didn't exist. So I'm going to do this one because that's how it's written. So we won't do this one right now. So -6, the opposite, to zero out a -6.
Positive.
Yeah,
Positive.
perfect. Which means you're going to do the same thing to the 9. You're going to add 6, bring down your n over 5. That's gone. And then 9 plus 6 is 15. Much cleaner, much easier problem to deal with. Now we're going to multiply by
5.
perfect. Multiply both sides by 5. This cancels, it's gone. Leaves you n equals, and I believe
75.
thank you. I was going to do it in my head. That is never a good idea. And you can always check your work. You take your answer and you plug it back into the original equation. 75 divided by 5, it's going to be 15. 15 plus -6 is +9. So you did it right. Kind of cool, huh? All right, let's do, how are you guys feeling about these? You will not see these as often. You might get one on your GED test. You may not get any. You'll get lots of these. This style with the multiplying and the extra numbers. These just aren't as common, which is too bad because they're pretty easy. They look scary, but they're really not bad once you're comfortable with them. So let's go to, so these are two-step equations. Let's go to a little bit longer. See, they can get a little bit longer. It's okay because you know the process. So let's do number 5. Let me get a clean piece of paper. So 5 is 3r plus 7 equals 10r plus 28. So our goal is the same. We want to get it down to a variable on this side or whatever side of the equal sign and a number. One variable equals one number. This time, you know, when we were looking at the two-step problems, we got rid of the extra number. We just happen to have an extra variable and an extra number. So we're going to do one at a time. Let's get rid of the 3r first. So we're going to take away 3r, which means we're going to take away 3r from here. Ignore the numbers. You're only dealing with the variable issue. So this is gone. Bring down your 7 equals 10 minus 3r is 7r plus 28. You've already cleaned it up. That's your first step. This is a multi-step problem. Now,
if we pick the 10r, the same equation.
Absolutely. And I will do it with the 10r after we do this one. You can pick these to start. You cannot go wrong. You can pick the 7, you can pick the 3r, you can pick the 10r, you can pick the 28. It doesn't matter where you start. You will end up at the same answer. It's kind of, yeah, it's kind of fun. So here we've got this extra 28. Now we have to get rid of that. So we're going to say minus 28 on both sides. That's gone. This is going to be negative 21 equals 7r. And now it looks more familiar. We were just doing the
divided.
Yeah. We're going to divide out that 7 on both sides. Good job. That's
Yeah.
leaves R.
-3.
Perfect. -21 divided by 7 is -3. So I'm going to do the same exact problem, but I'm going to get rid of something else first. So let me
Oh.
put this one up. And it was 3R plus 7 equals 10R plus 28. This time, let's get rid of the 10R. Minus 10R, that zeroes it out there, minus 10R here. That leaves us -7R plus 7 equals 28. Now we have to get rid of this 7. We're going to take it away from both sides. We've got -7R. These guys are gone. 28 minus 7 is 21. And I'll put these side by side in a second. And then we're back to a much more familiar problem. Divide out -7R by -7, 21 by -7. These are gone, leaves you R equals 21 by -7 is -3. So look at that. You started with two different variables. Let me see if I can get these side by side. And
Same answer.
they follow the exact same pattern. This one, we got rid of the 3R. And so this part is a little bit different, but we keep going and we end up with the same answer. -3 equals R, R equals -3.
It doesn't matter, right?
It doesn't matter.
Negative.
You can start anywhere you want. If you have a thing about sevens, you can get rid of the 7 first. If you don't like the 28, get rid of the 28 first. It doesn't matter what you get rid of first because it's step by step until you get to the answer. And that's what's really cool about these is they're not going to change. As long as you're comfortable with the process of getting rid of one thing at a time, they can give you a huge long one and you just say, okay, I'm going to get rid of an R, then I'm going to get rid of another R until I'm down to one number variable. Then I'm going to start getting rid of all the numbers until I'm down to 1. And then I'll keep going until I have one variable and one number. And it's okay if these are reversed. This is the exact same answer. -3 equals R is the same as R equals -3. It does not matter that they are reversed. Cool, huh? I think it's kind of cool. And the great thing about this is once you're comfortable, you can do algebra and you will see when we do geometry, these keep popping up. They don't go away once you're done with algebra. They're all over geometry. So if you thought you were getting away with them, no. They'll keep showing up. All right, let's do a couple more of these longer ones, and then we'll do some distributive property. And I think your brains will be full by then. All right, let's do number 9. We've got 3x minus 8 equals -4x plus 13. Which one of those characters do you want to get rid of?
Minus the 8. This one.
This one right here?
Yes.
Yeah, let's get rid of that -8. So to zero it out, we're going to add 8, which means we're going to add 8 to the number on the other side. And then bring down the stuff you didn't use. We didn't use 3x. This is gone. Bring down the equal sign. Bring down the -4x. And 13 and 8 is going to be 21, I believe. Is that right? Yeah, 21. So now we have to get rid of the negative 4x because we only have a 3x over here. We have to leave it there. So we're going to get rid of negative 4x by adding 4x to both sides. This is gone. Now we have 7x equals 21. It looks much more familiar now, doesn't it? One more step. We're going to get rid of that 7. Divide out the 7 on both sides. Your x equals 21 divided by 7 is 3. What do you think?
Easy.
Nice. I like that. Let's do one more and then we'll do the distributive property.
In
Which
the
is
GED, the exam, they gave us like this equation. I
you
don't think.
only have 1 or 2 equations like this. And then when you do slope and graphing, these equations are used almost all the time. And even in geometry, when you start solving with formulas for geometry, you'll come back to this. So it happens a lot. Let's try 7x plus 10 equals 3x plus 50. Big numbers sometimes. I don't love big numbers because it's easier to make an error when the bigger the numbers, but that's fine. Which one of these would you like to get rid of?
Mm. 50.
Yeah, let's get rid of that 50. So we're going to take away 50. And that zeroes this side out, but that means we have to take away 50 from here. Numbers. So bring down 7x, because we haven't done anything with it yet, minus,
negative 40.
yeah, equal
3x,
3x,
0.
and that's
Yeah,
gone.
0.
Now
we have to get rid of the 7x because if we got rid of 3x, we don't have an equation.
Negative 3. Yeah, 7.
So that leaves us with negative 40 because that side's zeroed out. And that will be 3x plus negative 7. X will be negative 4x. Now, again, it looks a little more familiar. We need to,
Divided.
yeah, we need to separate that negative 4 and it's x.
Negative 4.
Perfect. Bad guy.
X is 10 equal 10 positive.
You've got it. That's it. So if anybody is still struggling with negative numbers, do not feel bad. Everybody struggles with negative numbers. It changes the game. You know, it'd be much easier if we could only deal with positive numbers. That's how you learned numbers. But we have these negatives, and if you find them confusing or you're not sure, wait, is that going to be negative, positive, what? Let me know. I've got some sources for negative numbers.
Yeah.
It's just practice. That is the only way to start recognizing whether an answer is going to be negative.
Yeah, because sometimes the sign make the answer incorrect.
Yes. And GED is not above. For this answer, you could very easily have this selection on GED, and this annoys me. I don't think it's nice. So they would do something like negative 10 equals x, 10 equals x, negative 5, or 5. See what they do? So you can for sure know that these two are not correct, but now you're stuck trying to figure out if you did it right. Is it negative or is it positive? It's really easy to get, especially when you're under stress. Your brain doesn't work as well when you're stressed. And so they do things like this just to kind of mess with you. It's not great. I don't love it. All right. What do you think? What do you think of these problems? They're a little bit longer.
No, it's very interesting.
Yeah. And you
Because
just take it
therapy,
one
it's
number at
made,
a
you know, if you've had people that are in your family, maybe you've been through it. Doesn't make you so sick anymore as it used to because they have all this anti-nausea medicine. It just makes you profoundly tired. I could get up in the morning during that time. By 9 o'clock, I was ready to go back to bed.
All right, now the last biggie, and not everybody loves these. This is anytime you see a number and then an equation inside parentheses. This is called distributive property. GED will never ask you to define this, but they'll use it like this in the directions. Use the distributive property to solve each of the equations. Don't let that throw you. You'll get used to seeing equations like this with a number and then parentheses with another equation in them. You'll do the same thing no matter what they say up here. So here, let's do number 2. We've got 2 times x minus 2 equals 6. So distributive property means you're going to take this number, you're going to multiply it by the first thing in the equation, then you're going to do it again by the second. So first thing we're going to do is 2
So
times
X,
yeah, minus 2 times 2 4. Perfect. So see that it's really not bad. And it cleaned right up. Now it looks like something we've been doing. And you go right back into it. Get rid of the extra 4. Bring down your 2x. 6 plus 4 is 10. And then you have to get rid of that 2, separate it from the x. And you've got x equals 10 divided by 2 is 5. So that is all distributive property is doing. It means you're distributing the equation. So it's 2 times this equation, but you can't do anything with x minus 2. So you have to take the 2 times the x, bring the sign down, 2 times the number, and you have a new equation, no parentheses. It's much cleaner. Let's do a few more of these. Whoops. Let's do, is there another easy one? Let's do number 3, and then we'll do a little, where they get a little more complicated. So we've got -4 times x plus 2 equals 16. So we're going to start with the -4 times the x. Will be in -4 times x is just -4x. Bring down the plus sign. -4 times 2 is -8. So you cleared the parentheses. It's a much cleaner equation without the parentheses. Now it looks familiar. We're going to get rid of this 8. We're going to add 8 to it to zero it out. Add 8 to 16. And we've got negative, bring that down because we haven't used it, equals 16 and 8 is 24. Then we're going to separate the -4 from the x. And this is gone. That leaves us with x. And 24 divided by -4, good guy, leaves town, bad for the town. 24 divided by 4 is 6.
Oh,
Not,
that's good.
yeah. And
But
what's,
I do have question. Sorry, I do have question for the when we clear the parentheses.
and your question was about clearing the parentheses? Uh-oh, did I lose?
I have a question about the like sign. The second step, you did the negative 4x plus negative 8, and the plus sign. I did the wrong. I'm doing right now in my notebook too.
What does yours look like?
Like the second step, when you get rid of the 8, like plus 8, and then again plus. Yeah, this one, the second
Yeah.
one.
So you could also do this. Is that what you did?
Yes.
Yeah, you do not need that plus sign. Anytime you've got plus a negative number, you can drop the plus sign. And so whatever way it makes the most sense to you, because it's extra here. It's
Yeah,
still,
that's so confusing.
yeah, it is. It can be really confusing. But a negative number pushes out the plus sign. Anytime you've got, say you had something like 2 plus negative 2 equals, it equals 0 because it's the same as if you said 2 minus 2. So that plus sign is extra. Some people like to have it so they can deal with, they can say, okay, well, it's 2 and negative 2. So if we did a number line, this would be 0,
First
1.
line, when you multiply that, like first step, like 4 multiply x, then 4 multiply 2. So you put the sign like negative with 8 because the negative sign with 4. That's why.
Yes.
Okay.
Yeah, it would be negative 4
Negative 4,
times 2 equals negative 8.
negative 8. Got it. Thank you so much.
Yeah, you're very welcome. It's a lot. There are a lot of little things that you have to think about. And it's not always fun, especially when you're testing. The last thing you want to do is worry about the details, but they kind of force you to. So you want me to do a long one? Look at those. Look at number 10. Let's do number 10. You may not be ready for number 10, but let's just do it so you've seen it. So we've got 2 times x plus 3 equals 3 times x minus 3. And again, you're just going to do one thing at a time. So we'll start with this side. And distributive property says we need to do 2 times x and then 2 times 3. So 2 times x is 2x plus 2 times 3 is 6. Bring down your equal sign. Then we'll do it again. 3 times x, 3 times negative 3. So 3 times x is 3x, and 3 times negative 3 is negative 9. Now it looks like what we were doing on the previous page. It's a little bit long, and we're going to pick one of them. It doesn't matter which one you pick. Let's get rid of, let's make it a pain in the neck. No, let's get rid of, what do you want to get rid of?
6.
Yeah, let's get rid of the 6. And we're going to do the same thing on the other side with that number. And that's going to leave us 2x on this side. The 6's are gone. Bring down your 3x. And negative 9 and negative 6 is negative 15. Now you have to get rid of the 3x because if you got rid of the 2x, you wouldn't have an equation. So we're going to get rid of 3x. Get rid of 3x. That's going to be 2 minus 3 is negative 1x, or just negative x. Same thing. Same exact thing. Equals negative 15. Now this is interesting. This is negative x equals negative. I should have thought about this. You're not going to love this. You don't ever have negative variables. Technically, this answer is correct, except you will never see a negative variable as an answer. So you have to turn it to positive. So no negative variable, no negative. And how do you change it to positive? Easy. You just flip it.
Yes.
Now it's positive, but what does that mean for negative 15? If you flip the x, what are you going to do to the 15?
Positive too.
Yep. This is the answer that you'll get on GED. Even though you solved it to here, this will be the correct answer. This will not be an answer. They won't force you to choose between the two. They will give you this.
Oh, how
And it-
about if, sorry, how about if we do like negative x? It will be with a variable negative 1x.
And this is the exact same thing as this. So
Oh.
1x
Negative 1/6.
as x. We just don't use the 1 because it's a single x.
No, for the sign, if we put over negative 1 equal negative 15 over negative 1, we can understand more, it will be positive.
Oh, right here. So
Yes.
when we did this, let me rewrite this. I get what you're saying. That's really good. That's excellent. If we had negative 1x equals negative 15, just like we did before, we can get rid of that
Yeah.
1.
Yeah. And
By-
when we practice like this way, it will be more understand.
Perfect. Oh, that's so smart. Good job.
Yeah.
Does that make sense to everybody?
Yeah. Because most time when we get negative x equal negative 5, we think that this is the answer, the final answer.
Yeah. Perfect. I really like that. I didn't even think about that. And that's what we've
Yeah.
been doing when it's any other number. So it makes sense.
Yeah.
Negative
Yeah.
x is 1x, get rid of that negative 1. And there's your answer. That's the answer.
Yeah, it's not, we have to write it for not forget.
Right.
Mhm.
And don't worry, they will not give you this as an option. You know how I showed you, sometimes they do that. Where did I put
But
those?
they give the tricky stuff, you know?
Yeah, yes. They won't do this to you. See how these are all positive? They will never give you an answer that's a negative x.
So if we have like this, like 4 options, what's the like easy way to solve? First we have to solve, then we find the answer. This is very long.
Yeah, it can take time. This is why the timer on the GED is so bad for people, because it takes a long time to draw these out. You cannot do these on the calculator because of the equal sign. Your calculator will not let you, it'll let you do this. It will not let you do this because those calculators do not have an equal sign. So you can't type in the whole equation. If you could, you would have the answers instantaneously and you could whip right through the test. But because it doesn't, you've got to write it out, and that takes time. Yeah, the timing on the test is the worst part. If there was no timer, every one of you would pass the first time through because you'd
Yes.
have enough time to think about it. You'd have enough time to breathe. You know, if you felt like you were starting to stress out, you could take a moment and just get yourself back together, and you wouldn't be worrying about the clock ticking down.
I'm
So
still
what do you
confused.
think of
Like
those?
X is equal, you said like positive 15. How you got the positive 15, like 15 over 1?
Let me grab that. What did I do?
Okay.
I moved it. I did not move these things. Aha. All right, so I'm going to do this one again because it's a long one. And I'm going to do it just the way that we did when you've got any number in front of X. So let's go back to 2 times X plus 3 equals 3 times X minus 3. So we have got 2 times X is 2X. 2 times 3 is 6. 3 times X is 3X. 3 times negative 3 is negative 9. And then last time we got rid of the 6. So let's do that again. Let's get rid of 6. Make sure you take it away from both sides. That leaves you with 2X on this side equals 3X minus 15. We have to get rid of this. The 3X goes away, minus 3X. That's going to be negative 1X. These are gone. Bring down your negative 15. Now, you're going to divide out the negative 1 on both sides. That gives you negative 1 divided by negative 1 is just plain old X. And negative 15 divided by negative 1, good guy, or sorry, bad guy leaves town. It's good for the town. Does that make more sense?
Yes.
Awesome. And bit by bit, you will get these, all of these equations, whether they've got the parentheses in them or not. It's just step by step by step. So in this case, you do the multiplication for distributive property, both characters inside the parentheses times 2 or times 3, whatever. Then you start the process one step at a time. And boom, you get down to one variable, one number. Some of the shorter ones, I have a shorter one. So these are shorter. You know immediately what you have to get rid of because you only have one number with a variable. So you want to get rid of this extra number, zero it out, do the same thing on the other side. Then you've got negative 14n equals 56. Divide out that negative 14 on both sides. 1n, one number. Nice. All right. So those problems, if you've got them, that is your foundation to all algebra. And really, it'll be all the way through graphing, which we'll pick up on. If you guys are comfortable with these, we'll do some, on Monday, we'll do some combining like terms. And then the following Monday, we will start graphing. So make sure you're comfortable with these. If you need more homework, I've got lots of resources. I can send you mountains of these just so you can practice. And don't do a ton every day. Just do a few a day, 2 or 3, because that's how you're going to commit it to long-term memory. And that's where you want it. You don't want to do an entire page and then come back next week and think, wait, I knew how to do these last week. because it went into your short term. You want it long term. So do 1 or 2 or 3 every day or every other day, and that will gel in your head. And so when you're in the middle of the test, you won't even think about it. You'll be looking at a problem and you'll do it automatically. And that's huge. That will save you so much time and so much stress. So any questions before I let you go?
Thank you so much. So much.
Welcome.
Yeah, you are so great teacher. You helping us a lot. Thank you so much.
Oh, you're very welcome. Yeah, I want all of you to get in there, get this test done and out of your hair.
Yeah, you guys are amazing, really. Thank you.
All right, and I'll see some of you for language arts, social studies tomorrow, and science on Wednesday. And
Same timing, right?
Yes, same time. And
Okay.
check emails, because I'll have the links to get in on the emails rather than you trying to hunt around in the group. It just gets really confusing to try to find them in the group. And you're all registered, so don't worry about registering. You're done. You don't have to deal with that. All right, I will see some of you tomorrow, and the rest of you have a great week, and we'll see you next time.
Bye.
Thank you so much. Bye.
You're so welcome.
Thank you.
Thank you very much for your time. Thank you very much.
You're welcome.
Bye-bye.